toy type, auth type. I can have no auth. I can have a jot, whatever JavaScript signatures or whatever. Or I can just provide a basic user info with a username and password, which here I've just represented as a tuple, string. And then just maybe some funny function to kind of print out some things. And I think this is pretty standard. Now, if we look at a first kind of introduction to polymorphic variants, you would write it something like this. And it looks pretty similar to what we just saw, with the exception that, well, now we're writing these backticks in front of each variant name. And the type signature changes. So OCaml is telling us that, now the type signature is something which is jot with a string, or a symbol, or something that is a no auth, or something that has a tuple called user info. And funnily enough, because we ignored the second element of that tuple, it's just saying that it's polymorphic on that. So depending on where we use this function, it's gonna try and resolve this type, which is a funny name. So we'll talk about pros and cons of this at the end. But I think that's a worthwhile call out, is to just denote that this is polymorphic on that second argument as well. And I think the notation here is pretty interesting as well. So just kind of, I think this symbol would be pretty interesting. This is basically a less than. So basically the type of this would be this or anything less than this. So, either one of those two, or either, two of whichever one of these, or just each one of those individually. So we'll see how that looks like later. I can spin up a REPL. And of course, we could also just define it like we did before, but with only some. No, it would be those or a subset of those.
What was the question?
And
sorry?
we could actually. So yeah, I think it was Mark that asked, wouldn't it be those or more of those? And I said that no, it actually can't. It can be these or a subset of these.
Right.
And we could tweak this function to make it these or more of these, any more of these, and this symbol would change to a greater than. And I can show that how that works. And that actually gives us even funnier results, I guess. And I think that, as the OCaml manual says, the type signature may still be refined. So depending on where we use this, the type signature of this is going to get resolved to a certain thing or another, which can be funny too. We'll see that in an example later. And as I said before, we could also just define it pretty similar to how we define it without polymorphic variants. If we can still assign polymorphic variants to a type alias, there's some funny syntax. So you use the square brackets, you still use the backticks, and then you just define it as such. And this can actually help us later down the road with other techniques that we can use, particularly when it comes to something that's called coercions. So I can have a separate type that is just assigned to maybe just a subset of what I initially did. And I can define a function based only on that subset, and then use a function that I defined previously. But the OCaml compiler just doesn't do, it doesn't just assume the subtype. Because if we look at it closely, the jot auth type, this thing that I'm highlighting right now, is actually a subset of the one previously. So then we tell the compiler that, hey, this type, actually, this value that has this type is actually a subtype of the one that I defined previously. And at compile time, the compiler will say yes or no. And this is, we call these coercions. I think the name might be misleading, because normally when we talk about coercions, we talk about runtime coercions. And then people, I think, tend to throw their hands in the air like, oh my goodness, this is a runtime coercion, how dangerous. So this is still type safe. This is a compile time check. The compiler will refuse to do it if I were to just change this somehow. Yeah, and as an example, just to kind of get us to start looking at some code, which I think would be pretty interesting. I took a look at, well, I've been having a look at Postrest for a while. It's a pretty awesome Haskell program that can turn your relational database into a REST API. So if here I have like a merchants table or whatever, then it creates like this CRUD for that merchants table. And more interestingly, it actually lets me query the table with some interesting query syntax using the URI. And this maps directly to what you would expect in your PostgREST database. So for example, this is less than, and I can only use less than with a number. This is in, and I can only use in with a number or a string. And I can also do conjunctions. So I can say, give me something that is greater than or equal to 5, and less than or equal to 10. Or I can do projections. So I can only select, if I wanted to, I could select a single column from that table. And PostgREST just knows how to do that kind of projection. And then there's other kind of functionality like full text search, which is pretty interesting. PostgREST just does like word stemming in different languages. Is pretty amazing. So what I wanted to do for this, it was particularly around the querying language. And I thought, what if I wanted to talk to a PostgREST instance and not have to write these things out as strings in my code? I would much rather try to just generate this somehow. Okay, so let's go to look at some code. So I took this opportunity, and I might make this code bigger, if you allow me. Like that. Can everyone see the code on my screen just fine?
It's good for me.
Cool. Thank you.
Yep, all good.
Thank you. So here I've defined, I guess, every single operator in like a massive catch-all type. And this is just saying, well, just catch them and just capture them all there. And I think that more interestingly, what I did is I defined a catch-all type for the values. So all the values that I can use in the database, which would be like null or a Boolean wrapper or an integer wrapper or float wrapper, and a string wrapper. And lastly, this kind of hack that I wrote in there, which is called string literal. Then I have just a condition type, which is something that would be trivial, like select from table where 1 equals 1 or where true. And then something that is just an operator, which is just saying something like some table field greater than or equal to something. So this is kind of what this captures. So this operator T has an operator type within it, which is just what I showed before. Yeah, and then what I do basically is I kind of hack around I have a subtype of the values that's called numeric value. And then I have something like simple value. So for things that only accept null or Boolean, and I should have a string value somewhere. Anyway, So this is only, so I should note that I'm working on a client library that kind of uses this to generate the query, and we're only focusing now on the query generation. So I'm not doing like inserts or deletes or anything. Because I am extremely lazy, I decided to just write a function called makeCondition, which takes an operator, a string, which I guess would be the field name, but I represent it as a string, I guess, again, due to laziness. And then it has a value t, which is that catch-all value that I showed before. But this is still like pretty unsafe, because I could say that the operator was something exclusively for a string, like, you know, like string compare or something. But I could give it a number, and then that would be like, yeah, that wouldn't make any sense. So I'm, even though I am hacking, I'm still trying to look for some kind of nice usability and try to prevent errors. And likewise, like, what if I gave this an operator that's only valid for, like, say, numbers, and then I gave a value t, which was a string? That still wouldn't make any sense. So I'm planning to simply just export the convenience functions that try to just capture the values that are valid for each one. So for example, in the like function, which is when you do something like select from this table where a certain column is like another string, I only give it a string value t. And then I just call the makeCondition function, which some operator, in this case like, the field name, which is just here called a, which I should stop. I should name my variables better. Yeah, there you go. And then I say, all right, and the v, which is this string value, and then I coerce it into a value t. And the reason why I do that, well, first of all, is because if I don't, and I just say v, whoops, then the compiler is going to complain. It's going to say, hey, this expression has a string value, but I am actually looking for a value t. So I have to say, hey, don't worry, because string value is actually a valid value t. And then once I do that, then the compiler is happy. And it checks it again, like it does this at compile time. I do pretty much the same thing with almost everything. So for example, in this case, I have to kind of break up the in operator. So if I check that a column is inside of a string or is inside of a number list, then I kind of just did this. I said, well, string value t, and then I have to just coerce it again. And in this case, I guess it's interesting to denote that we can also coerce to like list of values. And the compiler will still understand that. So it still does understand that, for example, a list of string values can be coerced to a list of value t, right? Something about call variants. So there's a whole interesting subject about how this works. Yeah, and let's see if I can actually spin up a REPL and try to showcase that. Okay. So I can make a condition, any kind of condition, to say, so not numeric in, number in. And this is like my field is not in some int 10 or int 11. Just kind of making it up. And that's not the syntax, that's the syntax. Oops. Whoops, there you go. And then I can just print that out. I can say string of condition for condition, and it prints out that according to the PostgREST query syntax, it prints out, what I wanted. It says, I'm trying to check that my field is not in this list, right? And if I were to say that something like string, then it complains, says, hey, this expression is not valid. So I want it to be a numeric value t, and that's not what you gave me, right? And I can combine these. So I have, combination operators, negation operators, but I guess that's interesting because there's nothing really special about it. Yeah, any questions so far?
Carlos, did you think about
Yes,
using the GADT for your, how you're only exporting the constructor functions there? Did you think about using GADT for those instead?
I guess, to be quite honest, I didn't, simply because I was looking for an excuse to use polymorphic variants. if I'm being totally candid.
Okay, I think you could probably get some of the stuff that you wanted from GADT, but since you're such a fan of polymorphic variants, it makes sense.
Yeah, I am. So there is an absolute bias here.
And I guess I was going to comment that maybe you can recover some polymorphism by using modules to simulate type classes.
Yeah, so that's something that actually crossed my mind just recently, and I was about to give it a shot this week. Yeah, just to kind of modularize it a bit more, because right now everything's in a single types.ml module, and it's really hard to follow, hard to test too.
Yeah. I was thinking about those two operators that you have, one for numbers and one for strings. You could kind of, do the type class there.
Like here, yeah. And I think it should be this is something that I guess I'm not leveraging the module system enough, whereas I totally should. I could create maybe a module signature that represents each table, and I give it the fields and the type of each field, and then it just generates the functions without having to do separate names for them in a lot of situations, but with the types already, resolved according to the type of each field. And I think that will make it a lot easier to follow, and the code look a lot cleaner too.
Yep. Cool.
Yeah. So I guess because I like them, I like polymorphic variants, but I think there is a discussion to be had, I guess, on the cons. So the reason why I like them, for example, is because I'm one of the rare few people, I guess, that really enjoys the subtyping mechanisms that exist in OCaml. Not only just this, I also really like the object system. So I know that is really an unpopular opinion, but I like it. That's the first thing. But I think that another thing is that polymorphic variants, and even this is going back to the OCaml manual, can be sometimes less what they call type discipline, because I can use a polymorphic variant in any function that I define ad hoc, and I don't have to predefine the types. And I think that, as just kind of taking that conversation a little bit further, we can get into a conversation about semantically, what does it mean? Are the semantics on the type, or are the semantics on the each variant? So understandably, there can be turn out to be more confusing code. So that's another con, I guess. And the last con, I guess, would be the error messages can start to get really funky with polymorphic variants, because you get these type signatures that are just, right, admittedly strange. These sort of things, right? Also, you know, like this operator doesn't exist in the REPL, so you know it's not like you can just write a function and test it. So that's another kind of like detail that people deserve to know.
Can you really not use that operator in the REPL? I've never run into that before. You can't copy and paste the colon arrow or whatever.
I'm pretty sure, like I've tried this and I have failed. Let's just give it a shot. Maybe.
Admittedly, I don't use the REPL that often, you know, OCaml, but
yeah, it's pretty. I found it strange. Let's paste that in. Oh, probably should have pointed.
It just occurred to me that we use the word row types for polymorphic records. So we should call these column types.
And I had a, oh, well, you can use it when you define like functions using let expressions.
yeah.
But you can't say something like, you can't say this. It's weird, right? It says syntax error on the rocket.
But you'd have to bind it to a let, wouldn't you? But if you bound that to a let, that would work.
So maybe I can say
like a let underscore or something.
And then I can say F is a, that works. So you can do it as a, in type signatures as well. Yeah.
Yeah. So I think it's just the way you were calling it there.
Yeah, that's potentially.
What does JWT auth mean as a thing? Like you can't really have that as a what would you expect that to print back if it worked? I'm not sure.
Potentially something like nothing, maybe. If it returned nothing, I think it would be fine. But yeah, or something like maybe in the Scala REPL, sometimes you can type like implicitly do something, and that also works. So maybe, yeah, it just depends. But yeah, that's also a good question. Like I don't know what I expected. So
yeah.
But if you use it in type signatures, yeah, cool.
If you use it in the let expression before, it's a expression on the left-hand side and a type on the right-hand side. But that JWT underscore auth colon greater than auth, that's a type on the left-hand side and a type on the right-hand side. So could you try
Yeah, so like
JWT foo colon greater than auth?
Let's see, what's that? I'll follow you.
Sorry, I just meant backtick with no let, backtick capital J lower WT foo, and coerce that to an auth.
Like that?
Yeah.
Like that? Let's see.
Yeah.
Still complaining.
Yeah, that's weird.
Yeah. Yeah. Yeah, because we did use it here, for example, when I defined, sorry, there's no syntax coloring here, but yeah, we defined it there. So that's interesting. But yeah, I guess I have to learn the REPL a little bit better. Yeah, and yeah, so I was talking about the cons. Yeah, I think there's also a number of pros to this. So I guess the canonical or the popular JSON library in OCaml is JSON, and it does use these polymorphic variants. I think they make for, I mean, and I may be just taking from the OCaml manual, you know, they talk about reusability, or they make for code adaptability like a little bit better, but I honestly, I'm not at the point where I can say that's definitely true or that's definitely false. To me, I guess it makes like for really flexible style of programming, sometimes if you need it, which I think is actually something that is positive, but can like very quickly spill into the negative. So, you know, there's always that balance, I guess, that you have to strike. But that's been my experience with OCaml, with a lot of other things. It's that, you know, like you can choose how disciplined or flexible you want to be in a lot of ways. I mean, I think it's the same way with Haskell, but Haskell does enforce that a little bit more from my own experience, day-to-day experience. Whereas, you know, I just have like a whole lot of fun hacking around with polymorphic variants. And yeah, I have left some reading resources in the very last slide. And I actually will add something else here, which is advanced material, I guess, for OCaml variants. OCaml also has what's called extensible variants, which is obviously not going to be the subject today, but it's also quite interesting, I think, worth reading up on. And yeah, that's me.
Cool.
Thanks,
I just have a quick question about what happens to the equational reasoning. You still get the exhaustive check on the pattern matching functions?
So it depends. So when we talk about a type signature like the one that I defined, I'll just scroll up, something like this, you would get, depends on how you define it, I guess. So I could type annotate this to say that this is actually a function from, you know, the type alias to a unit. I can do that actually, just to kind of showcase that. Unit, cool, and it doesn't complain. If I say were to delete this line and keep the type signature, then it would complain. It would say, hey, you haven't pattern matched on this case.
Yeah. Cool.
But that's because I type annotated it. Because if I don't type annotate it, I'll show that. It's happy about it. It says, you know, fine, like
But it's going to infer a smaller type for
two.
your function.
Exactly. Yeah.
Yeah.
Yeah. So it, you know, as I said before, like you can still define, I guess, your types with polymorphic variants. So like this that I'm doing right now, you can still define like a type alias to polymorphic variants. And you can use those in type signatures with the added benefit that you can also potentially coerce other type aliases into functions that use this variant, this type alias. So it does make for a little bit more flexibility, but I do still believe that the semantics of things matter. So just because you coerced your type into some super type and used it in a certain function, I don't think it still means that you're going to be able to use that everywhere, or that it's going to mean the same thing, or that you can have like the same expectations across the board. So it's just something that I think you need to watch out for. You know, say you define like some subtype of JSON. Are all the JSON functions still going to be valid for your subtype, you know? And what are your expectations around that? So I think as long as you're conscious of that, like it's pretty good. I guess, you know, buyer beware. That's the only thing that I would say, you know, like watch out for. And I think the last consideration is that Jane Street says that, you know, they're slow. And also the OCaml manual, I think, says so, that they're slower than like typical variants. But it also has it says that, you know, that only applies for like deeply nested or like massive data structures. And so if you're running like a super tight loops and, you know, you need to watch out for performance, then probably don't use like polymorphic variants and just stick to regular old variants.
Cool. Thank you.
Cool. All right. Thanks, guys. I'll stop presenting unless anybody wants to see more REPL action. Take that as enough.